Hello my dear students, welcome back to NEET World. So here in this session we will be discussing the P block elements, that is for 2 marks question for your IPE exam. Okay, so it's a class 12 P block elements which is very important for 2 marks questions. See, P block elements is very important for 8 marks. First of all, LAQ question we can expect definitely from P block elements, right? And we have clearly discussed all the LAQs, whether it can be P block or it can be organic or it can be physical like electrochemistry or chemical kinetics. All these 3 chapters or 3 LAQs were already discussed. Okay, right. So if you haven't watched, you can watch that session in this playlist itself, in this channel playlist itself. You can go and watch it. Okay, right. So this is our C60 material. So this material contains all the important questions that must be focused to score 60 out of 60 in your IPE exams. Okay, right. So now how can you access this material? Yes, I will tell you everything. Just give a minute. I will be checking here whether audio, video, everything is clear. Yeah, so now what I am saying, yeah, this is our C60 material. Now how can you access this? See, just go to Play Store and download NEET World app. Okay, go to Play Store and download NEET World app. Just log in using your mobile number. Then just go to chat box and say like whatever the class you are. If you are a class 12th IPE, yes, you mention class 12th IPE MPC or IPE by PC, so that you will get your group subjects itself. Okay, right. You can use that PDFs whichever we are providing in the app. Okay, and make your preparation more productive and more effective. Okay, right. So now in this session we will be discussing the P block elements, very short answer type questions. Okay, right. Let me show you. Yeah, so here we have chapter 6 P block elements. The first question is about allotropy. So what do we mean by allotropy? See, this is allotropy. Allotropy. What do we mean by allotropy? See, there are some compounds. Allotropy. What do we mean by allotropy? See, there are some compounds like there are some atoms or elements which exist in more than one form right now. For example, carbon can be exist in graphite form, diamond form right now. So these are the 2 allotropes of carbon now. Okay, so now look at here. See, allotropy is a property of an element to exist in 2 or more physical forms called allotropes. Okay, what I am saying, allotropes means this is the property of elements to exist in 2 or more physical forms. Okay, 2 or more physical forms, not physical states. I am saying it's a physical states. I am saying it's a physical forms. Okay, now see, for oxygen, what are the allotropes? You can say oxygen, like oxygen atom has 2 allotropes, that is O2 and O3. That oxygen molecule and ozone molecule are the 2 allotropic forms of oxygen, you should say. Okay, and for carbon, what I told you, the graphite. Okay, this is one allotrope, and the diamond the another one. So these are the 2 allotropes of carbon. Okay, right. So now what exactly, how do you write in the exam? The allotrope, like allotrope is a property of elements to exist in 2 or more physical forms, okay, called allotropes. They form similar chemical properties. Correct? These 2 forms, allotropes have similar chemical properties but different physical properties. What they have? Different physical properties. Okay, right. For this, again, you can expect. I mean, if you have studied in class 11th, carbon and its its elements like carbon family, like group 14. So there you are seeing detailed discussion about carbon and diamond now. I mean graphite and diamond now. So there you have studied that graphite is used as a good lubricant, and graphite will be good electrical conductor, whereas diamond cannot be. Okay, so those are different physical properties are there now, because there are 2 allotropes showing 2 different physical properties. So we can say they may have similar chemical properties but physical properties are differ. Okay, right. The next, look at here, the next question here, nitrogen molecule is highly stable. Why it is? Why it is stable? Okay, so the 2 nitrogen atoms in N2 molecule, whenever we are writing N2, so how do you write? There are 5 valence electrons in nitrogen, right? So I am placing there's as a 3 dots here and 2 dots here on each of this nitrogen. Okay, and once after doing this, the 2 nitrogen atoms in N2 are held together by very strong triple covalent bond. Okay, so this is one bond, the second bond and third bond. Like this, 3 bonds are present and nitrogen atoms in the nitrogen molecule. Okay, so this results in extremely high bond dissociation energy. See, between the 2 atoms, more the number of bonds, more is the strength of that particular molecule. The more is the bond strength. See, the bond dissociation energy is very high due to presence of these 3 bonds between the 2 atoms. Okay, more the number of bonds, that is called bond order. Greater the bond order, greater is the bond enthalpy or bond dissociation enthalpy, you can remember. Okay, next. Therefore, nitrogen molecule is highly stable and relatively unreactive at room temperature. Yes, so nitrogen gas is very unreactive at room temperature. Therefore, it can be used in many applications, in daily life applications. If you see the car or vehicles like bus tire, if you see, the tire will be filled with the tube will be filled with the nitrogen gas itself. Okay, so again, so yeah, this is one of the important like example that explains that is because of its high bond dissociation energy only nitrogen gas is used in the vehicle tires, vehicle tubes, you can remember. And one more good example is nitrogen gas is used as an inert gas. So it will be a inert gas, it means it won't react at normal temperature. That's why it is filled in that chips packets. If you see, it will be bubble, right? It is completely filled with the air, right? The chips packet will be completely filled with the air. Why it will be that? What is the air present in it? It will be containing major quantity of nitrogen. Why it will be? So nitrogen will not allow the chips, that aloo chips, whatever we are seeing, potato chips, whatever we are seeing, that will not allow to undergo oxidation further. Okay, so that's why they will remove oxygen and they will fill only with the nitrogen gas. Okay, this is the best example because nitrogen here creating inert atmosphere. Okay, then next, so what are the 2 reasons they are saying why it is highly stable? Due to the 2 nitrogen atoms are held together by very strong triple bond. Okay, between nitrogen and nitrogen, due to the small size, overlapping will be very effective. That makes these 3 triple bonds very strong. Okay, this is a one good reason you should remember. Okay, then next here we have few more things to discuss. What is the tailing of mercury? How it is removed? So what do we mean by tailing of mercury? See, mercury exposed to oxygen. See, tailing of mercury means when liquid mercury, we know at room temperature mercury will be in liquid state, right now. So when liquid mercury reacts with ozone, ozone is O3. Okay, it loses its metallic like metallic shine. See, if you have seen this like mercury directly, so it will be having some silvery shiny nature. Okay, so that will be loose, that will be lost when it is exposed or when it is reacting with ozone. Okay, so then next it loses its metallic shine and starts sticking to the glass. Okay, so what it will do, it will start sticking to the glass. So due to the mercurous oxide O is formed. So this process is known as tailing of mercury. Okay, it's a very simple one. See, zinc like mercury upon exposed, upon reacting with this ozone, what happens? It will forms mercurous oxide. So this mercurous oxide, whenever it is forming, it loses its meniscus nature. Okay, so it loses its metallic luster, metallic shining, and also it will be losing its meniscus nature. Therefore, it will be sticking to the glasses. Okay, the glass walls of the glass container. Okay, whatever the container you are taking. So due to the formation of, why it is so? Because due to the formation of Hg2O oxide. Okay, so now it is removed by either shaking with water or by passing through the liquid mercury. So what we need to do, so that whatever the process, whatever the product we got, you just shake it with the water, so that it will loses its whatever the oxide is present, that will be lost and again comes back to its original state. That's good. Okay, so now what happens when chlorine is react with a Slagle lime? This is one of the important thing to discuss. See, what happens when chlorine reacts with Slackle lime. So what do we mean by Slackle lime? It's a calcium hydroxide, na, CaOH twice. Okay, so chlorine with calcium hydroxide. This will form bleaching powder. That bleaching powder is nothing but that bleaching formula is what? CaOCl2. Okay, so when chlorine reacts with a dry Slackle lime, the bleaching have increased. 2,3 CaOCl2 is formed. Okay, calcium oxychloride, CaOCl2 is formed. Okay, so now it's one of the important formula, CaOCl2 we are seeing now. So in this case you need to remember that calcium will be attached with the one chloride directly and another bond with oxygen and chlorine. Okay, this is how it will be existing. Okay, why I am adding this extra point? Yes, this is useful for your competitive exams like NEET, JEE and EAP set. So here you are seeing chlorine is directly attached to the calcium. So we know calcium is a metal, always be in the positive oxidation state in the compounds, right? So here it is in Ca+2 oxidation state. So chloride ion is more electronegative, so chlorine is a negative form. Okay, Cl minus. Again, between oxygen and chlorine, we know oxygen is more electronegative, so oxygen is in -2 oxide form. Okay, and here chlorine is there now, so chlorine is less electronegative than oxygen, that creates a positive charge on the chlorine. Okay, so there are two oxidation states for chlorine in CaOCl2. This is the thing you need to remember here in the calcium the bleaching powder formula. Okay, one chlorine is in -1, another one is in +1 oxidation state. This is the important point to be remembered here. Okay, right. Then after this, here we have few more things. The next question here, how is chlorine manufactured by decons process? See, these model questions from P block elements, you can expect 8 marks question also in the same manner, either manufacturing of chlorine or manufacturing of nitric acid like HNO3. Okay, Ostwald process. The next sulfuric acid by contact process. These are some important method or manufacturing methods to be focused for 8 marks. Okay, remember that. And here we have a simple small 2 marks question from decons method. So just see here. In decons method, hydrogen chloride, it means HCl, is oxidized by atmospheric air. So you just take HCl gas. Okay, so this will be oxidized by air. Okay, atmospheric air. So how it will be converting? It will be giving you chlorine gas plus H2O. Okay, that's it. 4H. Yeah, that's it. Okay, so here I have mentioned exactly what the thing we require to mention. So 4HCl plus O2 gives rise to 2Cl2, 2Cl2 and 2H2O. That's it. This is what you need to mention. Okay, so now what is the catalyst here? See, in decons method, hydrogen chloride HCl is oxidized by atmospheric oxygen. Okay, in presence of the catalyst here is CuCl2. What is the catalyst used? CuCl2. This is the thing you need to mention. Okay, CuCl2 is a catalyst, and what is the temperature that should be maintained? So 723 Kelvin. 723 Kelvin is the temperature to be maintained for production of chlorine gas. Okay, so this is how you need to do. Okay, that's it. Then next we'll move forward. Yeah, the next few more questions are there. Write the reactions of chlorine and fluorine with water. It's again easy and important. See, there is some difference that you should also remember for your competitive exams. See, what they are saying, fluorine is a powerful oxidizer, oxidizing water to O2 and O3. See, reaction of F2 and Cl2 with water. So, F2 reacting with water, see, F2 reacting with water to produce HF plus oxygen gas is released. See, what is the product formed here? O2 gas is released. Okay, so now here F2 is oxidizing water. Okay, here -2 oxidation state is converting into 0 means oxygen undergoing oxidation. So because F2 is a powerful oxidizer, so it oxidizes others and reduces itself from F2 to F minus form. Okay, this is one important thing. And just now compare with the chlorine reaction. See, when chlorine is reacting, chlorine plus H2O, this will forms HOCl. What it is forming? HOCl and HCl. See, here it is HF, here it is HCl. That is fine. but here it is oxygen gas is released, but here hypochlorous acid is formed, HOCl is formed. Okay, so it is a different scenario, no, different case here, right? So here oxygen is in -2 oxidation state only, but here it is 0 oxidation state in product. So O2 molecule gas is released when fluorine is reacting with water, but here it is forming hypochlorous acid. So these are the two major important differences to be remembered here. So one is the product formed here upon treating fluorine with water is HF and O2. Okay, when it comes to chlorine, it will be HCl and HOCl. So this is the difference you should remember for the reactions of fluorine and chlorine with the water. That's it. This is the only thing to be remembered here. Okay, then next, write any two uses of argon. So where do we use this argon? Okay, so it is used to provide an inert atmosphere for filling of electrical bulb. We know argon, krypton, xenon, neon, helium, neon, argon, krypton, all these are inert gases, right? So it means they are very stable gases. Okay, so they will be in the atomic form in the unreactive state. They won't react normally, right? So due to this reason, argon gas is used to create inert atmosphere in the electric bulb. Okay, so that it will be used in, it can hold a high temperatures also here, and it will not undergo any chemical reactions there. Okay, it is used in laboratory for handling air sensitive substances. See, air sensitive, see there are some chemical reactions which are highly sensitive to the normal air conditions, normal atmospheric condition. So in that case, what they will do, they will create the atmosphere, that reaction atmosphere by inert. They create the reaction atmosphere very inert by using such gases like argon, okay, or nitrogen gas. These gases are used to create that inert atmosphere in that reaction container. Okay, so this is what the one of the important application. Next, it is used in rectifiers and also radio valves. Rectifiers and used in rectifiers and radio valves. Okay, that's it. And one of the very 2 marks important question for your P block elements is, what is inert pair effect? This is the most commonly asked question. So what is the inert pair effect means? See, here I will tell you the definition and a clear explanation will be provided. See, the reluctance, what they are saying, the reluctance of outermost ns electrons. What they are saying, the reluctance of outermost ns electrons to participate in chemical reactions, chemical bond formation, is known as inert pair effect. Okay, let me explain you clearly. See, this inert pair effect concept is applicable for P block elements. Which elements? Only for P block elements. Now give me some examples of P block elements. See, carbon family, let us take carbon, silicon, germanium, tin, lead, like this if we consider. Now all these elements which we are seeing are belongs to 14th group, right? Carbon family elements. Okay, so now this is at the top. What is the electronic configuration for 14th group? General electronic configuration as ns2 np2 we are writing. So this is just 2s2 2p2, but if you go here, it is 3s2 3p2, and here it is 3s2 4s2 4p2. Like this, if you see, this n value is getting raised right now as we go down the group. Okay, so now what this inert pair effect says is, as we go down the group, only s orbital electrons will participate, only p orbital electrons will participate in reaction, not this s orbital. Only this p orbital electrons will be participating in d orbital in chemical reactions, not this s orbitals. That is what the inertness or the reluctance or inertness of this ns pair electrons to take part in bond formation. It means they are not showing any interest. This ns electron, this outermost 6s 5s electrons are not showing interest to participate in chemical reactions. Okay, only this p orbital electrons, only these 2 electrons are getting participated in the chemical reactions. It means what I can say, these 6s electrons, s electrons are showing inertness now to form in the chemical reactions. That is called inert pair effect. So again, once again I am defining the definition. See, the reluctance or the area of ns pair electrons to take part in chemical reaction by p block elements is called inert pair effect. Okay, that's it. Okay, now you might be having, sir, why it is happening, or why this inert pair effect increasing down the group? Yes, because as we go down the group, what happens, not only 6s and 6p. So inside here we have, what we have here inside, there will be 4 f orbital is there, 5 d orbitals are there. So these 4 f 5 d orbitals have very poor shielding capacity. Now what happens, the nucleus, whatever the number of protons, see down the group atomic number increases by very bigger number, right? So down the group nuclear force increases. So that will hold the valence electrons very tightly. The 6s electrons are very tightly holded by the nucleus. That's why they are not participating chemical reactions. That's it. So this is a simple way you can understand for this 2 marks question. Okay, right. Now listen this next question. What they are saying, SO2 can be used as anti-chlor and explain. Okay, so used as an anti-chlor. SO2 is used as anti-chlor because SO2 removes excess of chlorine. See, anti-chlor means removal of chlorine here, you can say. See, SO2 removes excess of chlorine used in bleaching, like for cloths. Okay, it reduces chlorine to HCl. Now what will do, it will do, so when we are using bleaching, so it contains chlorine, right? So that will be controlled, or that will be removed by, extra part of the chlorine will be removed by SO2. So it will be removed by SO2, and how it will be reducing? Now chlorine will be reduces to HCl, like chloride ion it is forming. Okay, hydrochloric acid is formed. Okay, so this is how you need to mention the chemical reaction also. So Cl2 plus SO2 in water forming H2 plus H2SO4. That's it. Okay, so now what are neutral oxides of nitrogen? Again, this is a very interesting and very easy and mostly asked question in your NEET, JEE and AP set exams also. Like oxides of nitrogen they will ask. So now what are the oxides active during heavy braking? I'll tell you. O, and it can be NO, and it can be NO2, and it can be N2O3, or it can be N2O5. So these are the different type of oxides we have. Now out of these oxides, only the first two oxides are neutral. What these are? These are the only 2 neutral oxides, and remaining all of these are acidic oxides only. Okay, so now what are the neutral oxides? See, nitrogen, where is this question? Okay, what are the neutral oxides of nitrogen? See, only these first 2 oxides are neutral, remaining all of them are acidic oxides. So the neutral oxides of nitrogen are nitrous oxide, that is N2O, and nitric oxide, that is NO. Okay, N2O and NO are the only 2 neutral oxides. Remaining all other oxides are acidic for the nitrogen atom. Okay, remember this. So they will ask which of them are highly acidic. More acidic is which one? So down the group oxidation number increase in, I have written last one as N2O5. So that will be more acidic compared with the others. Okay, greater the oxidation state of that oxide, greater will be its acidic nature. Okay, that's it. You can remember in that way. Next, nitrogen exists as a diatomic molecule, whereas phosphorus is a P4 tetraatomic molecule. Why it is so? See, we know nitrogen will be like N2 form we are writing, whereas phosphorus will be in P4 form. So what makes the difference? Because nitrogen, phosphorus, all this belongs to same family, like group 15 only, right? So why nitrogen is in diatomic form, whereas phosphorus has a P4 form? Why it is so? Because a nitrogen are having very small size, like it's a small size and a high keep the head negativity. Due to its small size and high electronegativity, it forms multiple bonds. What it will do? Nitrogen and nitrogen, between 2 nitrogen atoms, it will be having multiple bonds. Okay, it forms multiple bonds and exists as a stable diatomic molecule. Okay, it will form multiple bonds and exist as a stable diatomic molecule. Whereas phosphorus here, P4, because phosphorus, when it comes to phosphorus, it will be in V4, because it cannot make this multiple bonds due to its larger size. See, because phosphorus has a larger in electronegativity, it cannot form stable multiple bonds, but prefer to form a single bond. P4, it will be like 4 phosphorus if you write like this. Yes, so like this it will be making some connections. Okay, so only single bonds are formed between them, like P and P will be there will be single bond connection. Okay, like that we'll get a tetrahedral kind of shape. Okay, exists as a tetrahedral molecule, that is P4 molecule. Okay, next here we have 2 or 3 more questions. Let us finish so that complete 2 marks questions from P block is completed. Okay, so now how is nitrogen prepared in laboratory? Write the chemical reactions involved there. See, nitrogen is prepared by laboratory by following methods. So first one is ammonium chloride. See, treating an aqueous solution of ammonium chloride with sodium nitrate. Again, these reactions, whatever here I have mentioned, 2 reactions are also asked in JEE NEET exams also. Just remember them. See, treating an aqueous solution of ammonium chloride with sodium nitrate. Ammonium chloride and sodium nitrate will get N2 gas and H2O and NaCl is formed. Now thermal decomposition of ammonium dichromate. See, ammonium dichromate is heated. What is happening? N2 gas is releasing and H2O is produced. Okay, so N2 plus H2O is produced here. Chromic oxide formed. Okay, then next NH3 forms hydrogen bonds, whereas PH3 does not form. Why? See, what do we mean by hydrogen bond? This is also important 4 marks question. They will ask define hydrogen bond and what are the types of hydrogen bonds, give some examples. 4 marks question. It's very easy and interesting. See, what do we mean by hydrogen bond? First of all, see, the hydrogen bond is nothing but it's an electrostatic force of attraction between an electronegative atom and hydrogen atom attached to the another electronegative atom here. See what I am saying? The lone pairs of this electronegative atom will be in connection or having electrostatic force of attraction with the positive charged hydrogen. This is partially positive charged hydrogen. How it will be getting partial positive charge? Because it is attached to a more electronegative atom. Due to that reason, this bond get polarized as H plus and a partial negative charge on electronegative atom. So like this, for example, here I am writing ammonia. If you see NH2 and 1 hydrogen, I am writing like this. See, hydrogen atom is attached to electronegative nitrogen atom right now. So hydrogen gets negative positive charge, oxygen nitrogen gets positive charge. Okay, like this. Okay, and beside this, let us say I am writing water molecule like this. Now what happens between these oxygen lone pair electrons and hydrogen? There will be electrostatic force of attraction because lone pair electrons, see, this is partial negative charge on oxygen due to the electronegative difference between these 2 atoms also, right? So due to that reason, the electrostatic force of attraction between hydrogen atom which is attached to electronegative atom and a more electronegative atom adjacent to it, that electrostatic force of attraction is called hydrogen bonding. So this kind of hydrogen bonding is possible only in ammonia. So why possible only in ammonia? Because nitrogen is smaller size now. So nitrogen atom is smaller size, having more electronegativity. Okay, so ammonia forms hydrogen bonds, while phosphine PH3 does not, due to significant difference in the properties of nitrogen and phosphorus. See, phosphorus is having a little larger size and its electronegativity also very less. Therefore, due to that less electronegativity nature of phosphorus, it cannot polarize the bond. It cannot polarize the bond as effectively as in case of nitrogen in ammonia. Therefore, it cannot make hydrogen bonds. Okay, so see here, the first reason is electronegativity. The nitrogen atom is smaller and has higher electronegativity, almost 3.0, and compared to phosphorus atom which is only 2.1. So due to this reason, only ammonia is in ammonia only forming hydrogen bonds, not phosphine. Okay, next reason is polarity. The high electronegativity of nitrogen in ammonia creates highly polar NH bond. This generates a strong positive charge on hydrogen atom, enabling it to form an effective hydrogen bond with a lone pair of adjacent nitrogen. Okay, that's it. Okay, so what's the conclusion here you can make? pH bond in pH3 is very less polar due to lower electronegativity, that it prevents the hydrogen bond formation. That's it. Okay, next one last question here we have. See, from P block elements, from very short answer type questions, I have provided 14 questions. Okay, mostly from these 14 questions only you will be seeing one in your final exams. Okay, right. So first of all, cover these 14 questions, then if you have time, yes, you can focus on the other questions also from this chapter. Okay, right. Look at here. What happens when white phosphorus is heated? Okay, what happens when white phosphorus is heated with concentrated NaOH? Okay, so NaOH solution, like sodium hydroxide solution in inert atmosphere of CO2. See, when white phosphorus is heated with concentrated sodium hydroxide solution in inert atmosphere like CO2, so it will undergo a decomposition reaction occurs leading to liberation of phosphine gas. See, white phosphorus P4 in basic medium like NaOH undergoes a disproportionation reaction. Again, the same reaction is equally important for your competitive exams. Okay, P4 with NaOH undergoes disproportionation reaction. So now what are the products formed? One is phosphine, that is PH3, and another one is NaH2PO2. Now they will ask for oxidation states of phosphorus in the final products formed in the disproportionation of white phosphorus. So here it is in +1 oxidation state and here it is in -3 oxidation state. Okay, so these are the things to be remembered from P block elements. I hope you have followed complete session, discussion of complete P block elements, very short answer type 2 marks questions. Okay, right. In the upcoming sessions, I will be discussing remaining chapters. I mean, what are the remaining very short answer 2 marks questions are there and 4 marks questions are there. Okay, we'll discuss all those. If you are new to this channel, just click on the follow button, and if you haven't watched our previous live discussions on either IPE sessions, or if you are preparing for EAP set also, you can just go and watch the sessions that we have made on EAP set. Every day we are coming up with free live sessions for EAP set also. Okay, right. So thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.